I'm going to start the recorder first and make sure that it is recording. Okay, that's great. And we can bump up the sensitivity a little bit. There we go. All right, so that's that. All right, you do have one homework assignment, and that's why we need to talk about how to turn in your homework assignment. Your homework assignment is in Getting Started. So in Getting Started, you have a homework assignment. It is called Hello Your World. Okay, so it's not just Hello World. You have to kind of make changes to the Hello World program. How many people still remember the Hello World program? Okay, if you don't remember, it's not the end of the world. I'm going to do the whole thing today. So what I'll do is I'm going to show you what the assignment looked like from the perspective of me first, and then from your perspective, how to turn it in. Okay, so for this homework assignment, I want you to put all the files into a single folder, and the name of that folder is lowercase hello. Okay, so you kind of have to observe these conventions, because I'm going to grade the homework assignment at least semi-automatically using a script. So it's not going to take hello with an exclamation point or uppercase H hello and so on and so forth. The case is important. The file containing the source code has to be hello.cpp, and CPP usually stands for C++. So if you use Codeblocks or if you use Linux, that's a convention that most programs use anyway. Okay. You can use the program that I wrote in previous classes, the one that uses printf, as a blueprint for yours. Okay, just to make minor changes to it and you're done. This particular assignment is not about C++ programming. It is about you having the right tools to do your homework assignment, and two, knowing how to turn in your homework assignment. The point value of this assignment is only 5 points, probably out of hundreds of points as a total throughout the entire semester. So it's not going to be a heavy point value type of homework assignment, but you want to get it done just to make sure that you know how to turn in your homework assignment. Okay. So your program has to output something like this, hello, and then your first name's world. Okay. So you have to replace this part with your actual first name. So I don't want to see any submission that prints hello first name's world, literally. Okay? Do you guys get that point? Okay. So in the case of me, okay, if I were to turn in my homework assignment, it would just have to print hello text world. That's all. I don't think there's any Wayne in this class, otherwise it would be kind of funny. Some people have watched that movie. Some people are way too young to even know what is Wayne's World. Yep, I can see that. Okay, to turn in your homework assignment, you will have to zip up the entire folder into a single zip file and then upload the zip file to Moodle. If you use a virtual machine, you will have to use the command line program called zip to do it, to create the archive file. This is the command to do it. You have to do it from outside of the hello subdirectory. Okay, I'm going to show you exactly how to do it in Linux. In Windows, you just have to navigate to the hello folder, right-click on the folder, and I think is it send to using the send to option in the pop-up menu window. You can say send to zip file and something like that, and that will automatically create the zip file. Okay. If you use a virtual machine, you will also have to use WinSCP or FileZilla to transfer the zip file to the host environment or hosting environment, and then use a browser in the hosting environment to actually upload the file. Okay, so a lot of steps, if you're doing it that way, I will show you exactly what to do, if you use that particular way to do it. Are there any questions before I go through the demonstration? No questions? Okay. If there are no questions, I'm going to use the long way of doing it first. And since I'm already using Linux, I'm going to be redundant and actually make use of my virtual machine. Okay. And my virtual machine is over here. And since I'm already in Linux, I'm going to use start.sh to start up my virtual machine. For those of you who use Windows and want to use the virtual machine method, you have to double click either Start32 for a 32-bit Windows system, or click Start64 in order to use it inside the 64-bit Windows system. Okay. So once you start up a virtual machine, it's just going to look like this. It will automatically start up the entire thing. So I'm just going to let this one run all by itself. It doesn't require any interaction until you get to the login prompt. All right, so now we have a login prompt. At this point, I want to point out two things. In the folder, let me show you the folder of the Linux subdirectory.
So take this chair?
No, you can take this one.
Thank you so much.
There you go. All right. So this is the folder. When you unzip the virtual machine, it will give you this folder. It already contains all the utility programs that you will need in order to do your homework assignment, to make connections to the virtual machine. One program is called Putty, and the other program is called WinSCP. Putty is a terminal program. Okay, it is what we call an SSH client program. It allows you to open up as many terminals as you need to into the virtual machine. So this way you can have one for editing, one to display man pages, one to compile and run the program, and one for zipping it up and do other things. Okay, you can open up as many terminals as you want. WinSCP is also the same kind of program as FileZilla. It allows you to transfer files from one machine to another machine. In this case, from the virtual machine to the hosting environment, or vice versa. Okay, you can also transfer in the opposite direction. Okay, are there any questions at this point about how to use the virtual machine? No questions so far? Okay. If there are no questions, I actually do have Putty installed in Linux, even though it was originally a Windows program. I also have one version for Linux. So when you start up Putty, it looks like this. It has a dialog box that asks you, where is the virtual machine and which port do you want to connect to. Okay. So at this point, you have to make sure the virtual machine is running first. Okay, because if the virtual machine is not running, there's nothing to connect to. So you got to make sure the virtual machine is first running. And then you can specify the host name. The host name is localhost, which means we are not going outside the network. We're staying on the machine. We're just talking to something else on the very same machine that you're making the connection from. The port number is 2200 by default. You can change that if you edit the batch file. Okay, you can change the 2200 in the batch file to something else, but by default it is 2200. Once you specify these two things, you can click open. And the first thing it will do is to give you a security alert. The security alert is here to make sure that you are connecting to the machine that you think you're connecting to. Okay, in case there's a man-in-the-middle attack, this allows you to identify, hey, I thought I was connecting to that server, but I'm actually connecting to something else. In this case, you don't have to worry about a single thing because it's a virtual machine running, on the same box. There's no way someone can really launch a man-in-the-middle attack, nor is there a reason that someone might want to launch an attack like that. So you just click accept here, and it will give you the login prompt. Let me see if I can change the size of the font here so that people can see the entire thing. I think resize does not change the font size, so it just changes the number of characters on the screen. So I'm gonna close this, and I will show you how to change the font size too. We'll go ahead and start Putty again. Go to the internet, start. Oops, wrong one. Go to internet, start Putty. Okay, when you start Putty, you can see you have all of these other options. You go to Appearance in Window, and in there, right here, Fonts. So it's under Window, but it's under Font here. You can change the font that you're going to use. and also change the font size, depending on what you want to do. So I'm going to use free mono, make it boldface so you can see it, from a distance. This looks okay for the time being. I'm going to use that. I'm going to go back to session here, specify localhost and 2200. Reopen it, and I'm going to log in as the regular user, and the default password of the regular user is just user. For this particular class, you can just use this account. You don't have to set up your own account for your own homework assignment. If you want to do that, that's fine with me too. So for this homework assignment, because I want everything under one folder called hello, the first thing I'm going to do is to create the folder called hello using mkdir or make directory. After that, I change directory to hello using cd, change directory, and now I'm in the folder called hello. You can tell that I'm in that folder because the system prompt has changed to ~/hello. That shows you where I am in the folder structure. Okay. At this point, I can use an editor to create a program. You can use Nano. For people who have never used VI before, Nano is more user-friendly. If you have used VI before and you want to really learn how to use VI, you can use VI if you want to. But I'm going to use Nano just for this particular homework assignment, and then it's just a text editor. It's that's all that it is. So I'm going to write the program right here. It has syntax highlighting, which is kind of cool. And this program should not be really surprising, right? So we say hello, comma, tags, apostrophe, world, exclamation point, line feed, close parentheses. Okay, so this is my program because tag is my first name. So with yours, you have to change tag to your first name, and that's the source code. Now I'm ready to get out of the editor in order to do some, in order to compile the program and so on. So instead of doing that, I'm going to open up another window just for compiling and running the program. I just want to show you that you can open up multiple terminals to the virtual machine. So we'll go to Putty again. I think there's another way to do this. If you right-click on here, at least for the Windows version you can do it, but for the Linux version it doesn't do it. For the Windows version, if you right-click on the title bar, there's an option to make a duplicate connection. So that way you can maintain the same settings using the same font and everything else, and you can open up another connection, just like that. The Linux version doesn't seem to have this feature, so I'll just have to go to Putty here and open up another connection. And the font is automatically reset to to the system default. If you want to say, I want to use this font all the time, and I want to remember to go to localhost port 2200. Once you specify everything like this, you can actually name a session and save it. So that way, the saved session maintains all the settings that you have already configured. Not 100% sure what happens when you have a portable version, because I don't know whether it saves to a file or whether it saves to the registry. If it saves to the registry, then it won't be very helpful because your registry stays on the Windows computer itself and not on the external hard drive. Okay? But that is something that you can look into, is to use saved sessions to save all your settings. And you can see that I'm opening up a second session here. I can log in as user and user again, and this time I can go to the folder called hello and just look at the content. There's nothing here because I have not saved the file from the editor yet. So the first thing I want to do is to do a Control-O. See this part here? The little caret symbol is the control key, and then the uppercase O means you have to type Control-O in order to save the file, to write out the file. So Control-O, it confirms, it confirms with you whether you want to save it as hello.cpp. You press the Enter key, and it will save the file. In the other terminal, now I can say ls or list, and you can see hello.cpp is now saved. Are we doing okay so far with these steps? You don't have to open up two terminals. I just do it so that you can see what it looks like when you open up multiple terminals. Okay. All right. In the other window, in this one, I'm going to go through the process of compiling and running the program. G++. Now, if you want to go through what we did in class, I specified -G as a switch to enable debugger, enable debugging, and then I specified -C to create an object code file, and then use hello.cpp as the name of the source code. If you encounter any problems, let me just go ahead and make a artificial error here. Okay, in other words, I'm intentionally missing the semicolon. Okay, because I want to show you that if you don't type in the program correctly, the compiler will give you syntax error messages, and then you have to go back into the editor, fix it, save it, and then you recompile. Okay, so if I introduce this error and save the file, Control O to save the file, and I recompile the program, it complains. I'm sorry, this is this is not using the boldface text, so it might be a little bit harder to read. I'm gonna close this. Control D can close the terminal when you're on the command prompt. I'm gonna reopen it so that we can choose a different font. Sorry? Okay, save it, and then open. All right, so we'll go ahead and recompile the program. I just want to show you what error message is generated because of this error. Okay, so it shows the error is in function int main. Well, we only have one function, so it has to be in main. It shows you on line 6, column 3, expected semicolon before return. Okay, so if you go back to the editor, Nano does not show line numbers. Okay, but you can type Control J, I think, to not Control J. There's one key that you can use to show your position. Control C right here. Cursor position is Control C. So if you type a Control C, it will show you that we are on line 5 at this point. Okay, on line 5 it is column 34. So what you need to do is to find out, okay, where's the error? The error is complaining that on line 6, column 3, which is here. So at this point, the compiler says, oh, I'm supposed to have seen a semicolon at this point. So that means the semicolon does not belong on this line, but the line before. Okay, so the fix is really just to go back to the, whoops, wrong window. The fix is to go back to the previous line and put a semicolon here. But C really doesn't care about line feeds. In other words, you can put a semicolon here, and that will fix the program as well. Okay, it just doesn't look right to you, or to me, it doesn't look right. Okay, because the semicolon is supposed to be a statement termination character, not something to begin a statement. So I would put the semicolon back here. If you forget to close the double quote, the error message will be different. Okay, so you have to kind of read the error message to get a clue of what is wrong with your program. If you have time, it is not a bad idea to artificially make syntax errors, just so that you know what type of message is generated because of what type of syntax error. Okay, is anyone getting that point? Okay, it's not a waste of time, because if you don't do experiments like that by artificially making syntax errors, the first time you get a syntax error message, you will have a harder time finding out what is the error message about and how to fix it. If you artificially, in a controlled way, introduce syntax errors, then you know what error it is. Then you just look at the message and say, oh, I see. If I forget to close a forget to close a double quote, this is the kind of error message that I will get. Because sometimes the error message may not reflect the actual error itself. Okay, so it is a good way to learn about syntax errors by artificially making those mistakes and then see what the compiler is going to say about those mistakes. You don't have to do it. If you have time, I strongly recommend that you do it a few times, just to make random mistakes, okay? Not random, controlled mistakes, and then see how the compiler is going to complain about it. Some errors are, other errors are like this, okay? You forget to close the open parenthesis, okay? Compile it and see what happens, what the compiler is going to complain about, okay? You can also do something like this, forgetting to close the end curly brace. Okay, these are all fairly common mistakes that most people make when they write programs like this. Okay. Are there any questions about how to use the editor in this case? Nano is the easy one to use. You just use the cursor keys to move around, Control O to save the file, and then Control X to exit from the editor. VI is a little bit more involved because VI has two modes. You have the full screen mode and then the command mode. So you kind of have to switch between the two. It's a little bit more involved. All right. So I just fixed the program, saved it, and this time when I compile, it compiles just fine. When it compiles just fine, I can now create the executable. To create the executable, I will give it the object code file, the .o file, and then specify the -o option, which is the name of the executable. The executable, when you test it, it doesn't have to be hello. Okay, the only thing you have to make sure is the folder name is hello, and then the program is hello.cpp. Those are the only two things you have to observe. The intermediate files, including the executable, can be anything. All right. So go ahead.
A quick question. So, for the uploaded homework, you just want the source code and that's it? The
No. The description of the homework specifically said it has to be a zip file in the folder. Yeah. But you can have additional files inside, I don't care.
So whatever is in the zip file, including the source code?
The zip file has to unzip to a folder called hello, and inside that folder hello has to be a source program called hello.cpp.
Okay.
So I just run the program here, and it prints hello text world. It does what it's supposed to do. Okay. So are there any questions about how to edit and how to compile, link, and run a program in a Linux environment?
So if I make any changes to the source code right now, I have to go back to everything like G++ -C.
Correct.
Again. And
Yes.
then redo it again.
Yes, if you make any changes to the source code, you will have to recompile and relink the program, because the object code file depends on the source file, and then the executable depends on the object code file.
So it will erase the previous one once I do that?
Yes, it will overwrite the previous one. Yep. Yeah, the only thing you don't want to overwrite, especially when the programs get larger, is the source code itself. The object code file is always, you can regenerate that from recompiling. The executable, you can regenerate it from the linker.
Override the source code.
A very common mistake is this. That would be bad. Because what this does is it will link the program just fine, but the output of the linker, which is the executable, is going to overwrite the source file. So you would lose the source file in this process. So this is the one thing that you do not want to do, especially when the program gets larger. Okay. All right. So now that I have everything done, in the Linux environment, you will have to do the zipping using the zip command. It is already installed in the virtual machine, so you don't have to worry about installing zip. So the command to do it is zip-r, which means recursive. Hello.zip, okay, that's the name of the zip file, and then hello, which is the name of the folder that I'm zipping up. And it gets everything done. Now we have a hello.zip file in the folder at the same level as the folder hello itself. Are we still doing okay so far with this process? Okay, you only have to do this if you're using the Linux environment. All right. But this is inside the virtual machine, and there's no direct way for me to access a file inside the virtual machine from Windows or a hosting environment. So the next thing I need to do is to run WinSCP or FileZilla in order to get to the file. Okay. FileZilla has a port in Linux. I have not installed it. Oh, you know what? I can't. Oh. And I have to choose one to install. I'm going to try the Wheezy one first. You don't have to do this part, because in Windows, FileZilla is just a MSI file, so it has an installer. But in Linux, I cannot install it because most of my other files are out of version. Just trying to think about how to demonstrate this part. I can do this. I'm going back to the folder where the Linux virtual machine is unzipped, and I will see if this works. It is a very roundabout way of doing something, but it might work. There we go. So WinSCP, when it runs, it looks like this. Very simple user interface. Make sure that the file protocol stays as SFTP. And then the host name, once again, is localhost. Port number is 2200. Okay. You can also, if you want to, specify the username and password in the dialog box. If you do not specify the username and the password in the dialog box, it will ask you when you make the connection. Okay, so it's not the end of the world if you forget to specify that. So once you have done that, you click login. And once again, it will make sure that this is the machine that you're connecting to. Click yes. And it looks like this. This is WinSCP running. When WinSCP runs correctly and make the connection, the left-hand side is your current hosting environment. In this case, it's a Linux box, but in your case, it's most likely the Windows side of things. The right-hand side reflects, the remote side, which is the virtual machine in this case. To copy a file from the virtual machine into your local environment is just drag and drop. Okay, so in this case, I'm going to my I'm going to my downloads folder here. So I'm going to copy hello.zip from the virtual machine to Windows, okay, quote unquote Windows, just by dragging and dropping it, and click OK. And you can see the hello.zip is now copied to the Windows side or the hosting environment. I have no use of WinSCP anymore. I'm going to close this window. And then back in the hosting environment, which is your Windows environment, you go to the homework assignment. And this is from my perspective. I will switch to your perspective. Just hold on 1 second. Switch to your perspective, and I'm ready to turn in the homework assignment. Under getting started, it is called Hello Your World. So when you log in to the homework assignment and you scroll all the way down, you will see this button here. It's add submission. When you click that button, it will give you another window to upload the file. Click here and then navigate to where the file was saved. To me, it was under the downloads folder, and it is named hello.zip. Click open and then click upload this file. So this will upload hello.zip to Moodle as a submission. Once you see this part here, it's not done yet, okay? Don't stop, okay? Make sure you click Save Changes. If you do not click Save Changes, the file is not going to be saved on the remote side. So you got to click, Save Changes. And after everything is done, if you see on your page, under File Submission, you have hello.zip as a hyperlink, you're done. Okay? You can even click hello.zip and download the file back if you want to double check what you have uploaded. Are there any questions about this process, how to turn in your homework assignment? Yep.
I didn't see how you access Windows SCP.
WinSCP?
Yeah.
If you're running it in Windows, it is just an icon in the folder that you expand to.
Okay.
Yep. If you use the virtual machine method.
Yeah. Okay.
Yeah. All right. So this is one way. Yep. Go ahead.
When you do copy it from the host to the remote, what is it actually doing? Is it bringing from Linux to your computer?
Yes.
Oh, okay.
Yeah. WinSCP and Putty are both what we call client programs. It relies on the computer that you're connecting to running SSH server. So if the other side is running SSH server and you have an account on the other side, WinSCP or Putty will allow you to make a connection between your Windows machine and whatever machine you're connected to. And that Putty allows you to do all kinds of command line stuff. You can edit the program, run it, and stuff like that. WinSCP allows you to do file transfer. So those two programs are related because they both use the SSH protocol. But one is for interaction and the other one is for file transfer. Okay. All right, so I have just demonstrated how to do it if you use the virtual machine in Linux. Some people might want to do it that way because eventually you will have to learn how to do it in other classes. Okay. But if you think, okay, this is too much work, I really don't want to mess around with the virtual machine and use the command line interface for now, you can always use Codeblocks. Okay, so I'm going to show you how to use Codeblocks to get exactly the same thing done. I have Codeblocks installed in Linux, but Codeblocks is Codeblocks. Okay, it doesn't matter whether it's running in Windows or Linux; it looks exactly the same way. Okay, this is Codeblocks. To me, it is busy, it is distracting, but that's subjective. So in Codeblocks, the first thing you want to do is to go to File, and then go to New, and then create a new project. Okay, so you create a new project. It's going to be just a regular C++ program. So let's see where we're going to put it.
Console application.
Sorry? Console application.
Yeah.
That sounds good to me. As I said, it's busy, okay, because it gives you all the options where, it doesn't really apply in this class. So you click Go, and welcome to the new console application wizard. It will guide you to create a new console application. Skip this page next time. It's going to be a C++ program. So in this case, don't click C, just click C++. It will make sure that the file is saved with the right extension. Okay, project title. This is an assignment, so this is assignment 1. Now you can see the project file name is automatically, using that name. So you might want to, make sure that it is something that you want to, use. So in this case, I'm just going to call it hello, just to be consistent. This is the important part. You have control of where the project is going to be created in. So don't take the default. Click, the ... here, and create your folder. Okay, make sure that you're using, the name that I want you guys to use. Okay. So this is my home folder, and I'm going to create a folder called hello. It's not working here, so I'm going to bypass that and create hello using the command line. It's already there. Okay. Okay, I'm going to remove this. Okay, so I just created a folder called hello, and it's It is. Yep. Okay. So just double click it, and then click open. Don't double click it, because if you double click it, it will look inside the folder. Yep.
On the previous screen, it was hello.cbp, not cpp.
That's the project file name, which is okay.
Okay.
Yeah, that's just the project file name. Okay, and then I click open. So now it is going to create a project in hello as a subfolder. The project file name is not important because I don't care about the project file name. I only care about the source code file name. Okay, and okay, it is actually saved in hello, which is not what I want. So maybe we should, make it one level less. Okay, if you do a hello, just make sure you create a zip file at the right level. Okay. So click next. We are going to use the GCC compiler. Okay, that's the default. It's good. Debug information, you can check it. Doesn't really matter. The rest, they're not really important for our purpose. Click finish. And now, we have, the hello project created. But at this point, it has no source code associated with the project. So now you have to create the source code for the hello project. And to do that, you go to sources, or you go to the project itself, and then you click maybe file, new file, and we want a C++ source file. And the file name with full path is going to be, it's not going to be main. We want to name it, hello.cpp. And then click finish. And now we can write our actual program. I'll include standard io.h and main. You can see that let me just kind of type very slowly. Okay. You can see that it has prompting. So when I'm done typing int, it shows me most of the things that people need to access that starts with int. Okay. It can be a good thing, can be a bad thing. For professional programmers, this is a good thing because they know what the other options are. But for beginning programmers, it can be a distraction because you look at all of the other options and go like, oh, but which one do I want? Okay, and you can also see it automatically understands that main is a subroutine. So when you press the I just pressed the open parenthesis, by the way. Okay, it closes it automatically. Okay, which is a good thing if you do this a lot. Okay, so just say void, and now I can do here. As soon as I press the open curly brace key, it closes the curly brace automatically and open up a new line for me with the right indentation. Okay, so all of that stuff is done automatically. So if you are used to typing your entire program yourself and you type really fast, this may actually be counterproductive, as it was for me. If you guys remember what I did earlier, I press the enter key and then I put in the close curly brace myself, which is redundant, and that's not what I want. Okay, so now we just have to write the program printf open quote, and you can see that the end double quote or the end parenthesis is automatic. It did it for me. So we just say hello \n. I still have to put in the semicolon here. Return 0, semicolon. I'm done with my program. Click save. All right. Now we want to test the program to see whether it runs or not. So we have to go to debug, and then we say start, continue. And it wants to change the perspective. Let's not save it. Can't launch console, xterm-t, program console-e sleep. debugger finished with status 0. You cannot launch the console. So maybe console is not the right type of project. So now I have to go back to hello and see if I can change the type of the project. So go to properties. Build target. Okay, here. Console application, GUI application, static library, command only. Maybe we should use commands only. Let's do the rebuild. Run. You must select a host application to run a commands only target.
You didn't select hello.
Say
Last
again?
window, you didn't select the hello.
Oh, I don't need main either, so I gotta make sure that I get rid of main here. The selected target is only running pre-post build step commands. Can debug such a target. Okay, so that's the wrong target. Okay, we don't want console. Let's try native. So it's done, but you cannot see the output. Let me see if the output is actually logged here. Breakpoint. Let's see if that works. Nope. All right, so I will have to figure out how to use code blocks. The Windows version may be slightly different. Maybe it's easier. You can probably find tutorials online too. You know, it's the.
It worked well for me. It worked well for me.
Okay.
The
Which
first
target
try.
did you specify?
Oh, well, maybe we can just start all over again and just do step by step the way I did it. So,
Okay.
I did a console application anyway.
You use console application?
Yes, and then saved it as a C++ file.
Okay.
Showed the directory to save in was a desktop. Printed hello, and then it created the main CPP, which already included the Hello World program, and you just can start like build and run it. So after it builds, it kind of checks for bugs, and then works that way.
Okay, but it does automatically make use of the main.cpp file instead of hello.cpp.
Yeah, you can rename it afterwards.
Yeah.
Or you can just blank create a new empty file and then save it as a C file.
Okay. Well, I'll leave it up to you guys to kind of play with code blocks, you know, to to figure out how to get it done. I can record a separate session, you know, when I get home. Yep.
How would turning in a codeblocks file work?
Okay, that's a good question. If you use code blocks, and at least the way I did it, if you use a file explorer and go back to to that folder, so let me go back to hello here. This is what Codeblocks created. It created files like hello.cpp. This is the only file inside the hello folder that I need. So Codeblocks, did everything correctly once I told it to create a folder called hello and then make the entire project in hello. The executable is going to be in bin here, and this is the executable. So it's actually quite a few levels down, but I think this is the program that runs. So I can double check on that one. So let me just go to the folder in debug hello and see if hello works. Yep. So no, this is not the right one. It says hello world instead of hello text world. So main.cpp is still the one being compiled, and I'll have to figure out how to get this whole thing to work first. Okay, sorry about that. Any questions about this process? Is everyone sufficiently confused by now? I say the virtual machine way is easier, just because I'm so used to that way of doing things. But Codeblocks, it's going to be easy once we figure out what options needs to be selected. So I'll have to figure that out. Yep.
You're going to teach us the syntax of all this code, right? We're not supposed to know all this already?
You are correct. You're not supposed to know the syntax of everything just yet. So at some point we're going to have to go through the syntax and kind of go through each one, one by one. The focus of this particular homework assignment is really just to make sure that you guys have selected one way to do your homework assignment and you know how to do it. And at this point, it's not quite working out yet because I'm new to Codeblocks. All right. So I'll just post another video once I figure out what options to use in Codeblocks, and then you guys can follow that. Right. But in terms of syntax, we are, this is the second topic, which is the basic syntax of C++. And when you click that, it will open up, this entire topic here. I think we're done with this one: types, expressions, and simple statements. Or not? No? Okay, let's go ahead and start with this one. We start off with expressions. An expression is kind of like this, okay? An expression can be as simple as just 2, 3, 5. Those are expressions. 2 plus 3 is an expression, but it involves the addition operator, okay? But this code is not very useful. In other words, if you just look at this expression 2 plus 3, it comes up with an answer of 5. But what am I doing with the answer? What am I doing with the value of 5? Nothing. Absolutely nothing. It does the calculation. It does not print it. It does not, store it somewhere. It's just there, okay? And it's gone, okay? So it's not useful. But there are operators that are much more useful than just the addition operation. Operator precedence. Have we talked about this one in this class? Nope. Okay. Operator precedence itself is a hyperlink. So you can open up a new tab. It brings you to Wikipedia that talks about operator precedence. Operator precedence has to do with, without the use of parentheses, how do we know which operator applies first? Okay. The example is here. The example is this expression here. If I just give you the expression of 2 plus 3 times 4, what is the result of this expression? It's 14. But why is it not 20? Okay?
What else the math rule?
Mm-hmm. It is a rule that people follow, right? So the rule has to do with, if you have addition and multiplication without the use of any parentheses, you always perform the multiplication first and then use the product in the addition. So in this case, 3 times 4 needs to be calculated first, and then you add a 2 to the 12, and that's why you come up with an answer of 14. Okay? But if you don't know anything about operator precedence, or understand that you have to perform multiplication first, then the answer is going to be 2 plus 3 is 5, 5 times 4 is 20. Okay? So that's why understanding the operator precedence is useful, because if someone else has written code and it looks like this, you have to understand that 3 times 4 is performed first, and then you add a 2 to the 12. So this link here shows you, the entire table of operator precedence with C++. So when you look at this table here, okay, the highest precedence is the : operation, which is to specify a namespace or scope. And then the next one down is plus, minus. Those are the increment, decrement, function call, array. So these are all at the same level. And then you go down to plus, minus, decrement, and I thought they were here as well. Suffix, okay. So the suffix is before the prefix. And then you move down to pointers, multiplication, addition, and so on. So if you have multiplication and addition on the same line in the same expression without using parentheses, then the operator multiplication will be performed before the operator plus. So this table gives you the entire. This is the entire table of all operators in C++. Do you have to memorize this? No. Okay, don't waste your time memorizing anything that you can easily look up on the internet. Okay, but you do have to know one thing: where to find it and how to use it. Okay, so those 2 things you do have to know, but don't waste any time to memorize all of these operators. So getting back to the notes here. All right, so that's basically saying that if you specify parentheses, it will be the same as putting parentheses around the multiplication, because it tells you that you have to perform the multiplication first and then add 2 to the product. All right, so what do we do with the values of operators? Nothing, okay? Because at this point we have only talked about multiplication and addition, which are not really particularly useful when it comes to what are we doing with the values. Okay. So getting back to the containing page, then we move down to the next item, variables and the assignment operator. So the first thing we want to do is to talk about variables. Are there any questions about the concept of a variable? If you have taken CISP 300 or 301, you should understand the basic concept of what a variable is. Okay? So what is a variable in general? It's it usually has memory associated with it, but what do we use variables for?
Store value.
Storing values, exactly. Okay, so you can store a value, you can retrieve a value from a variable. Okay, but what if you have multiple variables? How do we refer to variables? Okay, well that defines the scope. Okay, where a variable can be found. But how do we refer to variables? How do we differentiate between this variable versus that variable? Say again? Sorry, I couldn't hear you. Floats and integer. That's the type of a variable that kind of controls what you can store, what kind of value can be stored. But how do we distinguish this variable from the other? The name, exactly. Okay, the name of a variable. So every variable has 2 things at least. Okay, it has a name. Okay, that has to be unique. In other words, you can only have one variable of the name x. Okay, because if you have 2 variables of the name x, and you say, okay, take the value of x and multiply it by 2, then you have to say, but which variable x if you have 2, right? So in C++ programming, you have to make sure that you only have one variable of that name, or the name has to be unique. And then each variable also has a type associated with it. So in C++, a variable is an object that has a type, a value, and an identifier. The word identifier in C++ is almost the same as a name. Okay, it's just a way, it's a given name so that you can identify which one you're talking about. Question?
If you specify the same variable, you're going to get a subtractor.
Yes, that is correct. If you try to specify a variable twice, or have two variables in the same scope of the same name, the compiler will complain about it.
The identifier is just the name of the variable.
Yeah, but it is called an identifier in C++. A variable has a value, and the value can change, and that's why it's called a variable. It also has a type. Now, in some classes in pseudocode, we don't necessarily talk about types. Okay, but in this class, the type of a variable is important because C++ is what we call a strongly typed programming language. So it will make sure that the type matches exactly before it can perform an operation. So we'll talk about this, when we talk about the rest of this slide here. The value of a variable is also sometimes called the state of the variable. Okay. There are different kinds of variables in C++. We'll confine ourselves to local variables for the time being. So if you look at this particular, pretty useless subroutine, the name of the subroutine is main. It returns a type called integer. It does not have any parameters. And this is the line that is important to us. Okay, this is how you declare a variable in C++. You start with the type of the variable, and then you specify the identifier or the name of the variable, and then a semicolon to basically end that statement. So a declaration, a variable declaration in C++ is a statement, and that's why it needs a semicolon to end it. The // here means the rest of this line is comment. Okay, the compiler will not interpret anything after the / until the end of this line, but it will start interpreting again on the next line. So are there any questions about this particular line here? Yep.
I think you have kind of question.
Oh, okay, go ahead.
Okay, so you have a subroutine defined as main. So if a variable defined as x, can it be a subroutine x with a variable x?
That's a good question. I don't think so. The namespace is really kind of confined in C++, so you cannot use the same name for a variable and a subroutine. The reason why that is the case is because you can take the address of a subroutine, you can also take the address of a variable. So if they can be the same, then when you take the address of x, you don't know whether you're taking the address of the variable or the subroutine. So I think it is not allowed. Yep.
Two slashes, is that like rand and Visual Basic?
Yes. Remark. Yep. Yep. Yeah, it's just basically everything after the / is considered comment. Any other questions about? Yep, go ahead.
So why have you started with integer and main?
That's a convention. That is a convention. In C++ programming, the execution of a program starts with the subroutine called main. So you don't really have a control over the name main itself, nor what it returns. So it always has to return an integer type, because it is the convention that it has to return an integer type. Okay. Any other? That's a good question. Any other questions about this particular program?
Just one more time. What did you write void inside of
Void.
Void.
In this case, I use void inside the parentheses to tell the compiler that there are no parameters to this function, to this subroutine.
And you can write other things in
Say again?
there. You can write different things in there.
Yes, I can, but only limited to a certain options. Okay. The main function is really special, so it can only either have void. You can either specify void, which means I don't really expect anything. I don't expect any parameters. Or I can specify what we call argc and argv, argc and argv. It's way too early to talk about what you can pass to main. So for the time being, we'll just say that main is the starting point of an entire program. It returns an integer for no particular reason, and it has no parameters. Yep.
So inside the parentheses of main, if it were empty, that returns syntax?
I believe that is a syntax error because C++ requires you to specify what kind of parameters are expected, and having empty parentheses is not any specification. But there's a quick way to check it, right? So if you want to check that real quick, you can just go, create a program. I'm just going to go to the 10 folder for this. And all I need to do is to create a subroutine. Let's call that yada yada yada, and it's just an empty subroutine returning 0. And all I need to do is to compile the source code. I'm not going to run it. Okay, I just need to compile, and it takes it. So you can specify open and close parentheses, the same thing as putting void inside. So they serve the same function.
If you mark points off if it's empty.
No, I would not. Yep. Right. So any other questions about this particular subroutine? But the focus of this subroutine at this point is the declaration of variable x. Okay. The rest of the syntax is important, but the focus is how do we declare a variable. Any questions about this line here? X is a variable of integer type. That's how you read that declaration. Okay, no questions about this? Now this program obviously doesn't do anything because remember main is the entry point of your entire program. So as soon as we get into this subroutine, we know that we have a local variable x that is an integer, but right away it is going to return 0. How many classes talk about the return statement before this one? Well, I know I talk about it in my class, right? What does a return statement do? Yep, go ahead.
No, I was just asking what you talk about returning the value.
Yeah, it returns a value to whoever is calling main. Okay. Yep. So now that we know how to declare a variable, let's see what we can do with a variable. The first thing we can do with a variable is to change its value. Okay? So in this particular program, the first line is the same, int x is the same. It declares a variable, which is basically saying to the compiler and say, you know what, the rest of this subroutine may make use of a variable called x, and it has to store integer values. The line that I'm highlighting here, which is x equals 0, is the first line that actually makes use of the variable x. Well, most of you probably can look at this line and say, oh, I know what it means. It means assignment operation. I want to change the value of variable x to 0. And you will be correct. Okay, that is exactly what this line does. It has a left-hand side and a right-hand side. An assignment operation has 3 items. It has the operator, a single equal symbol. It has a left-hand side. The left-hand side of assignment specifies where am I storing a value. The right-hand side specifies what value am I storing. Are we doing okay so far with these 3 parts of an assignment operation? Is that okay? Okay. And this program is almost as useless because it initializes the variable x to 0, but I'm not making use of that value at all, anywhere else in this program. But let's just not worry about that part yet, okay? What we want to do is to ask or answer this question. In C++, is assignment an operator or is it a statement? What is the difference? What is the difference between a statement versus an operator?
An operator is assigning a value, and a statement is just saying what something is.
Not quite.
An operator is like a rule.
Well, they're both syntax. Okay, so they are each one is basically specifying the rules of where to put what symbols. Okay, the difference is an operator returns a value that can be used by other parts of, as it can serve as a part of another operator. Okay, think about this. I'm going to use, I'll just use a notepad here for that purpose. Okay, so let's take a look at this one here. 6 plus 5 times 6. Okay, there we go. Multiplication is an operator. As an operator, it has to return the value. So in this case, the multiplication operator returns a value of 30. Okay, what do we do with that value of 30? It is used as a part of the addition, right? So the 30 is being added to the 6. So as an entire expression, it gives us a value of 36. So this illustrates, what an operator does. It does something. It does something, but at the same time, it has to come back with a value. An operator gives you a value, so that that value in return can be used, in another part of another expression. Is that okay? That's an expression. A statement is basically a standalone thing. We'll do something, and that's it. The printf is kind of like a statement because it just prints something to the screen. It doesn't seem to do anything else. Okay. So in this case, the question is, if you look at assignment, which is an operation to change the value of a variable, is it a statement or is it an operator? If it is an operator, it has to return a value. Is that making any sense so far? So in the process of changing a variable, can that operation itself return a value? The answer in C++ is yes, it can. Okay, which is really odd. This feature is not found in Visual Basic or Pascal or most conventional programming languages, but in C++, the assignment operation is an operator. It returns a value. So because of that, you can do something like this. You can say x equals y equals 0, which basically will initialize both variable x and variable y to a value of 0. But the way it works is like this. This expression is basically the same thing as this expression here. And what it does is, because of the parentheses, it will first perform y equals 0 as an operator. Y equals 0 as an operator actually does two things instead of one. The first thing it does is to change variable y to a value of 0, which is what you would expect from assignment operation. But the second thing it does, which is not what most people think when they think of assignment operation, is to return a value of 0. So whatever you specify on the right-hand side of an operation, of an assignment operator, becomes the return value of the operator itself. So that means after it changes y to 0, as a whole, this particular operator becomes the value 0. And as a result, x is also changed to the value of 0. Is that okay so far? Does it make sense? Not really. This is a source of problems, okay? Because you can end up with a lot of trouble, not knowing when to use the single equal symbol and when to use a double equal symbol. We'll see the double equal symbol later. All right. So at this point, we are at a point where I'm not really quite sure this is doing what tag claims that it does. Okay. So what do you do when I talk about something? I say this program should do this, and you're not quite sure. Try it out. Okay. But how do we try out something like this? I mean, we haven't really talked about how to print the value of variables. So what do? We use a tool called a debugger. Okay? So this is also a place where you have to kind of decide for yourself what type of programming environment you want to use, because you will have to find out which way works best for you. Okay, so I'm gonna go to I'm just gonna call this test.cpp, and we'll have main as a subroutine. I just always use the void when there are no parameters to specify. Int x comma y. In other words, you can declare multiple variables on the same line by using a comma as a separator, okay? Which is kind of handy. Otherwise, you can divide it into 2 lines. That works the same way too. So I'm going to say x equals y equals 0 plus 1. So it's slightly different from what I have in the notes. What do you think happens in this case? Exactly. X ends up with a value of 1 because x equals 0 returns a value of 0. 0 plus 1 is 1, and that is being used as the right hand side to change x to 1. Okay. And then we have return 0 here. So here's my program. I'm going to test it. Okay. It doesn't do any printing. So how do I test a program like this without any printing? I'm going to shortcut the whole thing, so I will create the test, the executable right away. So we'll say gcc-g to include debug information, and this is the source code. Well, if I don't specify the name of the executable in Linux, it automatically creates a.out as the output. So this is actually going to be my executable. If I just run the executable itself, /, which means I want to run a.out of the current folder, it doesn't do a single thing. It doesn't crash, it doesn't do anything bad, but at the same time you don't really observe what it's doing, because there's no way to check the value of the variables when you run a program like this. So the way we do it is to use GDB as a debugger. Codeblocks has GDB already integrated as a component. So GDB is already integrated, and you can use the debugger in Codeblocks without having to install any additional component. When you run GDB as a command line program, it looks like this. It gives you a prompt. Okay, when you see this part here, open paren GDB, close paren, it is a prompt. It means GDB is now ready to take commands. Okay, you can tell it what to do. Okay, it doesn't do a single thing until you tell it to do something. The first thing I do is to use a list command here, or you can abbreviate it to just L, to look at the program itself. And in order to test whether this program does what it's supposed to, I'm going to rely on a feature called a breakpoint. In other words, I want the program to stop execution or pause execution at a certain point so that I can examine the values of variables at those points. The first place I wanted to stop is on line 5. So in GDB, I can say break 5, which means I want to put a breakpoint on line 5. Break, it can also be abbreviated to B, so B5 will do exactly the same thing. So it tells me I'm creating breakpoint 1 at a certain location. That's the location where line 5 is located. Okay. Now I can run the program at full speed. Yep. Roll sheet. I keep forgetting that. Thanks for the reminder. And I turn my phone to silent, so it doesn't matter whether I program a reminder on my phone because it's still silent. Yep.
You want a daily reminder? Do you want a daily reminder?
That would be helpful. Or I can set up a cron job, on my setup here. But okay, but getting back to the debugger here, run is going to start the execution of the program at full speed. Okay. In other words, if I did not put in a breakpoint, it would have run the program from start to finish in one swoop. Okay. But since I did put in a breakpoint, run, which can also be abbreviated to just R, is going to run up to the breakpoint and stop. Okay. When it stops at a breakpoint, it means it has not executed this line yet. It is just about to execute line 5 in this case. Okay. So before it executes this line, one thing that I want to find out is what are the current values of x and y. Those are local variables. This is a question directed to mostly students from my own class in CISP 300. When we trace programs involving variables, especially local variables. What is the initial value of a local variable? It is a question mark, okay? But why did we use a question mark to represent it? Can be anything, okay? So this is a good place to test it, okay? So I'll just go ahead and say print x and say, what is the value of x? Did I specify that number anywhere in the program? Nope. What about y? Can it be the same thing? Nope. Y has a different value. It can be anything, okay? So in C and C++ programming, when you declare a local variable, the variable can start with any particular value. Okay? The compiler has no obligation to initialize a variable for you to a particular value. Okay? So you have to keep that in mind. Okay, so now that I know y starts off with a value of 0, which is not very useful because it's going to get a value of 0 anyway. But x starts with a value that is not 1. Okay? So now I'm ready to continue the execution of the program. If you want to continue the execution of a program at full speed and not stopping at all, you can say continue or just C. Okay? But that's not what I want to do. What I want to do is to single step through this one line here and stop again right after this line so I can re-examine the values of x and y. So to do that, I'm going to do a single step or step, STEP, which is abbreviated to S here. Okay? So now I can re-examine the value of x and y. So once again, I print the value of x. X is now 1. Okay? Not the other number. And y should have a value of 0. Okay? So by using GDB, I can confirm what we have just talked about in class, that assignment is an operator. It returns a value that can in return be used in another expression for something else. Now that is something that you will not find in most other programming languages because it is just not a good idea. Okay? So if it is not such a good idea, why is it in C and C++? That's okay. You can quote other professors in this class.
He said that it's because you can do a lot of things with it. It's really flexible. It doesn't have as much rules as other programming languages.
Okay. Well, you kind of have to remember, who invented the C programming language for what purpose. Okay. For those of you who do not know, you can look up on Wikipedia. I'm just going to do a really quick search here, just so that you know, C++ or C inventor. Dennis Ritchie is one of the co-inventors of C, not C++, but C eventually became C++. So he is, also, inventing C++ because most of the features of C++ are basically C, and this is the guy. One of the two people who invented the C programming language. And by the way, he passed away, I think 1 week before or after Steve Jobs. Okay? Do you guys remember when Steve Jobs, passed away? It was big news. Everybody knew about it, right? Some people were really upset and some people were not. Okay? And during that time, how many people, read the news and go, oh no, Ritchie died. And the ironic thing is, without him and the co-inventor of C, there would not have been iOS. Okay? This guy and these two basically invented Unix. And in the process, the operating system. They were writing the entire operating system in assembly language at the time. Okay, this is back in the early 50s, early 70s, or late 60s. Okay, so they were programming. Okay, imagine this: they were building a castle, using grains of sand as a unit. Okay, so before long, these two, really, really experienced programmers decided, oh, this is really boring. Okay, we need better tools, but they did not have better tools at the time. So guess what? They made their tools, and what do you think that tool became? C. Yep, that became the C programming language. In other words, the C programming language was invented by extremely proficient and experienced programmers for themselves. It was never, ever intended as an instructional programming language like Pascal or Visual Basic. It was never invented or intended for beginning programmers like Pascal or Visual Basic. It was invented from day one for people who basically, invented the language itself. Does that kind of help explain why it has features that we as beginning programmers may find, why would someone put a feature like this here? Okay. Just to end today's lecture in good note, I want to point out there's a book. Just by the title of the book, you kind of know, what C really is. And I think you just look up C language rope long enough. That should be enough to find the book. This is the name of a book. Enough rope to shoot yourself in the foot. Rules for C and C++ programming. Because if you're not, go ahead.
Well, C is the first programming language?
No, C is not nearly the first programming language, but it does become one of the most popular programming languages today. And there are a lot of languages derived from C and C++. If you look at PHP, it borrows a lot of stuff from C. Java borrows a lot from C, and then JavaScript borrows from Java. So if you look at the ancestry of a lot of programming languages today, they trace the root all the way back to C. Okay, but this is a book. Obviously not everybody likes this book, but the title of this book kind of gives you a glimpse of all the traps that you can run into in C and C++ programming. Okay, the assignment operator is one of those things. Okay, at this point, it seems like there's no possible way to cause problems with the assignment operator. When we get to conditions like check for equality, then it will become obvious why why making assignment an operator is devious. Okay, so I'm going to end today's lecture here. Your only homework assignment is to do that one thing and then turn it in. I will do a recording so that you guys know how to use Codeblocks to do it. All right, start the recording.